here topic, because I would like to ensure that sometimes it is showing some other content. Yeah, are you able to see the screen view? I mean PPT. Only stop video only. Okay. Yeah, Kalyan, are you able to see my screen? Hello?
Yes, sir. Screen is visible.
Yeah. The problem number 17.10. Is it visible? Please
Sir,
reply. Yes,
visible.
no?
Yes, sir.
Okay. Okay. We
Hello, sir. Sir, you are not audible, sir.
Hello, sir.
Yeah, now is it audible?
Yes, sir.
I don't know suddenly what happened. By I mean my picture video is there. Video is visible. My video. Actually, I muted video.
We can see the presentation, sir.
You can see the presentation. I mean my picture is visible, or when my video is visible or not?
No, sir.
Because if I put a video, switch on the video, the memory space will be very high. That's what I'm asking. So only presentation slide visible, right?
Yes.
Yes, sir.
It is actually I checked that 1 hour presentation it's taking more than 1.5 GB if we see my video, I mean my picture, but only if presentation slides in terms of MB only our file size. Anyway, now okay, I mean earlier it was audible problem, I mean voice problem. Then now we again I read this problem, then we go for the discussion. A paras per gear 20-degree full depth invalid teeth consist of 20 teeth pinion messing with the 41 teeth of gear. The model is a 3 mm, model M is given, face width is given, B is given. The material, material for pinion as well as gear is given is steel, and ultimate tensile strength is of 600 Newton per mm square. The gear has been heat treated to improve the surface hardness. The surface hardness number is given 400 BHN Brinell hardness number. Now, the pinion rotates 1450 RPM. I mean NP is given. The service factor is given CS 1.75. Assume that velocity factor accounts for the dynamic load factor. Dynamic load and factor is and the factor of safety is 1.5. Now our aim is to determine the power of the gear. Earlier, this is a different problem. Okay. Now these are the given data during in the problem. So okay. Now ZP the mod number of teeth on gear pinion and gear and model service factor factor of safety gear. Now that come to the beam strength. What is the beam strength equation? I mean, we know already MB into sigma B into Y. I mean, sigma B is 600 Newton per mm square given. From this, we are able to permissible sigma B. Yeah, we can find it out. I mean, here 600 Newton per mm square is the ultimate tensile strength. From this, we can find it out permissible sigma B 1 by 3 into SUT. And sigma B is given, B also given, M is given, and Y also given. This is our beam strength. Now, wear strength. Why we are finding wear strength here? Because I mean, which one is the lower value that should be considered for the design. That's what we are considering. We are considering this also, wear strength also. I mean, wear strength, this is equation we already discussed, BQ dP into K. B is the face width and Q is our ratio factor. dP is our pinion, pinion, pitch circle diameter of pinion. K is our load stress factor. Now, here both are same material. Hence, pinion is weaker than gear. Hence, our design is based on pinion. Now, what is once just substitute the values, given values, be able to find out the wear strength. Q is a 0.16 into BHN. Already, this is a formula we already discussed early. BHN given, this is a 2.56. The ratio factor also we know the formula that 1.344. 1.344. Then substitute this equation, our wear strength equation. Finally, we are able to get wear strength of the gear. Now, come to the effective load. For effective load, we have to find out, because the effective load, I mean, we have to find out effective load. That effective load is greater than our beam strength or less than beam strength, or greater than wear strength or less than wear strength. We have to ensure that. Hence, we would like to find out effective load. Hence, when you like to find out effective load, we should know velocity factor. Here they have given service factor already given 1.75 already given. velocity factor we have to find out. Then velocity factor we have to find out. Then before finding the velocity factor CV, we have to find out what is the velocity, pitch lane velocity of the pinion. Now, pitch lane velocity of the pinion is now 4.5 dp and pi dn by 60. That's all. This is the standard formula. From this, we are able to find out the pitch lane velocity of the pinion. Then this is a 4.533. This is up to less than 10. Then when the pitch and velocity is at less than 10 meter per second, we have to use this empirical relation to find out our velocity factor. This is a 0.397. Now we already know that P effective load is equal to CS by CV into PT from this relation. Now CS by CV is equal to, now this is our effective load, but here PT is, we do not know, PT is not given in the problem. Now, even suppose given the problem, we have to find out the P effective also. That the P effective should be less than our wear strength as well as our beam strength. Okay. Now PT is, now PT is not given. From these relations, we are able to find out our PT. How do I find out PT? See here. Now, we already know that. Formula SB is equal to P effective load into factor of safety. Factor of safety is given in the problem, 1.5. 1.5. Our beam strength is given in the problem. We have found it now, 7,680 Newton. Now I have considered beam strength only, because beam strength is less than the wear strength. Hence, we have to find out this one. We have to consider for our design this only. So perhaps if I consider this wear strength, then I am going to have bending failure. Hence, for avoid that bending failure, I have been considered beam strength value. Beam strength value is less than the wear strength. Now we are in safe limit. We are, as per the wear strength concept, we are in the safe limit. As per the beam strength also, we are in the safe limit. Hence, I am considering the lowest value of beam strength Newton. Beam strength load 7,680 Newton. That is equal to P effective into PT. Now we would like to find out what is the PT. Now, because the final target is, our target is power. What is the power? When you are going to find out the power, we need PT. Without the PT, we can't find out the power. Hence, from this relation, we can find out our power. Perhaps, as I told you, I am repeating again. Perhaps PT is given, even though we have to find out our P effective load, that should be compared with our beam strength and wear strength. Now, PT is, we have found the PT from these relations. Finally, find out the power, rated power. What is the power equation? Power equation, before power is equal to power equation, we have to find out what is the torque transmitted. What is the torque? Torque MT is equal to PT into dP by 2. PT into dP by 2. From this relation, we are able to find out the torque. Then go for the standard equation. Power equation, 2 pi nt divided by 60 e power 6. Nt, 2 pi nt is nothing but np. T is torque, T is nothing but here mt. Now we know all the values. Finally, we are able to find out that amount of power transmitted is 5.29 kilowatt. Okay. Now now come to the next problem. This is also interesting problem. Now, see, it is required to design a per gear speed reducer for a compressor running 250 rpm. This is 250 rpm for which, gear or pinion speed. Now they didn't tell that. Okay, 250 rpm driven by 7 kilowatt power, 1000 rpm by electric motor. 1000 rpm by electric motor. Now you tell me, please, here this 250 rpm is corresponding to pinion speed or gear speed? 1000 rpm corresponding to pinion speed or gear speed? Please. In the last class,
Yes, sir.
250 RPM, right? I mean, Amarnath, are you telling 250 RPM is belongs to gear speed?
Sir, for 1000. 250 is for pinion.
Um, just to think about pinion is small wheel, gear is bigger wheel. Now you tell me which one is right answer. Which one is right? Pinion is higher speed or gear is higher speed? Okay, anyway, whatever you, at least you came forward to open your mouth. Okay, please tell me. Pinion is small wheel, gear is bigger wheel. Now, which one is belongs to 10,000 RPM? Which one is belongs to 250 RPM? Yeah, please, someone. Amarnath, are you understanding?
Yes, sir, understanding, sir. So according to me, the electric motor is having gear and they means and the 250 RPM belongs to pinion. But according to you, sir, 250 is pinion and sorry, 250 is gear and 1000 inch will be pinion.
Yes. Bigger wheel is, the revolution is less revolution as compared to smaller wheel when it's connected to the mechanism. Because that is the clearly we discussed, no, the speed ratio, gear ratio in the early. Okay. Okay. Anyway,
Yes, sir.
yeah. Now in the problem they have given the design, the center distance between the axis of the gears or center distance between the axis of gear and pinion should be maintained at 250 mm. The center distance is given between gears or between the gear and the pinion. The starting torque of the motor is 150. This is the service factor is given. Now the gears are made of carbon steel 50C4. I mean, here ultimate tensile strength is given 700 Newton per mm squared. The pressure angle is a 20-degree angle. The factor of set is set to for preliminary design. Okay, for the preliminary design based on the velocity factor. Now, what is our aim here? Design the gears as per the specific the dimensions. Assume that the gears manufactured meet the requirements grade 6. We are going to consider grade 6 to find out our errors. Mean total errors means that summation of error in pinion and gear. Okay. Now calculate the dynamic load based using our Buckingham equation and calculate the effective load. The effective load must be satisfied with our, I mean, shear strength and beam strength. What is the actual factor of safety? I mean, what is the actual factor of safety? Factor of safety more, it will be good for us, no problem. But what is the actual factor of safety? We are going to find out based on the bending failure, based on the bending failure. I mean, using then once we have found out the actual factor of safety, then use the same factor of safety against the fitting failure and specify the useful or suitable surface hardness number. Then based on this factor of safety, we are going to find out the hardness number. Now come to the problem. Now see here, these are the given data. Power is given 7.5 kilowatt. This is the pinion speed is given. Gear speed is given. Now this is center distance. We discussed during the, I mean, gear terminology. Terminologies per gear. During that time we discussed center distance, right? Now this is the ultimate tensile strength. This is the our I mean service factor. Now this is the grade of the grade of machining is 6. Now grade of machining is 6. Now we know the center distance. This is the formula we already discussed. A is equal to 1 by 2. Now first we are finding the module based on our beam strength. Okay. First we are finding the module based on beam strength. Before entering into that, we should know what is the DP and what is DG. DP, DG is not given, but they have given distance, center distance they have given between two gears or pinion gear they have given, and also they have given speed ratio. speed ratio is nothing but dg by dp or is np divided by ng. But one thing, in our problem, number of teeth, number of pinion, not number of teeth on gear, number of teeth on pinion not given. I mean, Zg and Zp are not given. Please keep in mind. Okay. Now from these relations, I mean, see these two equations. From these two equations, we are able to find out what is the dp and dg. Okay, simply simplify these two equations, then we are getting, I mean, dp, diameter of the pitch, I mean pitch circle diameter of the pinion is give, we can find, we have found it 100 mm. I mean pitch circle diameter of the gear, we have found it 400 mm. Okay, now I mean both, now again velocity, we have to find out the pitch and velocity based on the pinion, because this is, we are considering this is, I mean same material. Okay, pinion is weaker than the gear. Then this is our pitch and velocity, this is less than the 10 meter per second. Then go for this standard empirical relation, find our service factor. These are the things required to find out our effective load. Okay, now only the problem is, now Zg and Zp is not given when we are going for finding the beam strength, because our model is going to be, now our model is going to be defined based on the beam strength, because they're given in the problem. See here, the assumed that the gears yeah, in the problem we have to find out the model. So now we have to find out the model based on beam strength. Now when we are going for beam strength, we should know number of teeth on gear, number of teeth on gear, number of teeth on pinion. We don't know here. Only we know gear ratio, only we know center distance. From that we are able to find out only the pitch circle diameters. But suppose m is given, m is given, then we are able to find out number of teeth on gear, number of teeth on pinion. But m also not given. Hence I am considering the range from 20 teeth to 30 teeth. Then later I am going to ensure that my velocity ratio, I can later be able to find out number of teeth on gear and pinion later. Okay. Now now I am assuming, because m is not given, number of teeth and pinion and gear are not given. Now hence I am considering my number of teeth, the range of number of teeth on pinion 20 to 30. I'm assuming that 20 to 30. Then corresponding 20 teeth is 0.32 the form factor. I mean Levy's form factor is 0.32 corresponding to 20 teeth, right? Corresponding to 20 teeth, Levy's form factor is 0.32. Corresponding to 30 teeth of the pinion, now I am assuming 20 to 30 teeth, I am assuming that. Then 0.358. Now I am taking the average value of this range of teeth, 20 to 30 teeth. The average value is 0.34. Now this is my y value, Levy's form factor. Now substitute in this, then finally our beam strength also in terms of model, right? Now I mean anyway we are going to find out the model later, I mean using this beam strength, I mean effective load relation. Now anyway some of the parameters it will be required to find out our model. Now what is the amount of torque transmitted? From this 2 pi nt by 60 e power 6 relation, we are able to find out amount of torque transmitted, because the power is given already 7.5 kilowatt. The pinion speed is already given, right, 1000 rpm. Now once we know this, now what is the pt? Pt is required, because when we are going to finding, this is a pt. Because pt is required, because yes p is equal to, we know yes b is equal to p effective into fs. P effective is nothing but, yeah, here it's P effective is nothing but CS by CV. Now I mean CS by CV into PT, because I mean our model is going to be defined using this relation. Even that we discussed in the theory. While we discussed, we derived m from this relation. We derived m from the relation, this relation. Hence, I would like to find out my m model from this relation now. Hence, I need PF. When I'd like to find out PF, I need PT. Hence, PT from torque equation. If you know the torque value, we are able to find out the PT. Now PT is 1432 Newton. Now substitute here in P effective, then CS we know, CV we have found it already. Now CV is here, velocity factor, CS we know, service factor. From this relation we are able to find out our P effective load. Now P effective load we know, P effective into this is our SB. Now from this P effective into Fs is equal to SB. Okay. Now SB is in terms of now in model. SB is in terms of in model. Now from this relation, C and D, we are able to find out our model value is now 3.86 mm. Now I can consider as 4 mm. Now my model is a 4, and we consider the standard design base width is equal to 10 times of model. From this we are able to find out the base width. Now we come to this, once we know the model, now substitute here. Is that model dp is equal to, dp is equal to m into zp. From this relation we are able to find out our number of teeth on pinion, number of teeth on gear. Now number of teeth on pinion is 25, number of teeth on gear is 100. Now you verify this value. Your Lewis form factor 25. Now you see here. Now this is the silly the table. Just you verify the table, you are going to get this Lewis form factor is satisfied with our 0.34. This is corresponding to teeth 25 because we have been taken average. But whatever, finally we have found it. This finally based on model. Once we have found the model for mm, then finally we have found that ZP is equal to 25. That is, satisfying with what value we assumed the Lewis form factor value. Okay, satisfying with our Lewis factor value. Now this is number of teeth on pinion, number of teeth on gears we know. Now come to the beam strength. Now, once we know model, again substitute this equation, then we are able to find out our beam strength now. Now once substitute this model in this, now this is our beam strength. The beam strength should be greater than our effective load. But you may ask here, sir, here see here one thing. Here we have found that our model values in terms of 3.86. We have found that model value in terms of 3.86. But when we are considering model based on choice 1 and choice 2, we are considering round figure value, 4 mm or 5 mm or 6 mm, 7 mm, like that, right? Hence now I consider 4 mm. Hence I substitute here 4 mm. Hence obviously my beam strength is going to be greater than the effective load, P effective load. Suppose if you put 3.86, it will be equal to our this, right? But now we have been considered 4 mm round figure value. Hence our beam strength is now 12,693 Newton. Now based on dynamic load, because in the calculation we have to consider dynamic load to find out our effective load. Okay, the second part of the question. Okay, that's what now we are considering in the second other part of the question. We are considering the effective load, the dynamic load. Okay, now the grade is given. Now grade 6. This is the standard empirical relation for finding the errors in gears, and pinion. Now use this relation. Now before using this relation, this what is a pi? Pi is a tolerance factor m plus 0.25 square root of dp. From these relations, we are able to find out pi, and we are able to find out error in pinion. Similarly, we are able to find out error in cure. Then this is a total error, dp plus eg. Then now that is nothing but finally our total error is 25.76 micrometer. Okay. Come to this, I mean, when we are going to find out our, dynamic load, we should know deformation factor C. C is we can take it from the table. Already table, table 17.7, we have considered one more problem earlier. Okay. Similarly, you see this is the corresponding material and corresponding pressure angle. This is deformation factor is 11,400 Newton per mm square. Now we know E value from this, from this dynamic load, we know this velocity, pitching velocity, deformation factor. This is the error, phase width, and PT. This everything we know now. Substitute here. Finally, we are getting PD. Dynamic load is 6,448 Newton. Now find out our effective load, CSPT plus PD. This is our effective load, 8,596.89 Newton. Okay. Now what is the actual factor of safety now? Actual factor of safety, but see here, that is that has been asked here. What is the actual factor of safety against bending failure? Against bending failure, that's what I'm considering for finding the factor of safety. I'm considering, our beam strength, bending failure. They clearly mentioned in the design problem, only consider bending failure. Suppose I'm not telling bending failure or wear failure, then you have to find out again wear calculation, then which one is less value, that should be considered for the design. Okay. For finding the actual factor of safety, but clearly mentioned in the problem, the factor of safety to be found with respect to bending failure. Hence I am taking wear strength. This is actual factor of safety. The next part of the design problem is, based on actual factor of safety, we would like to find out the Bernal hardness number. Then when we are going to find out the Bernal hardness number, now we have to use this formula. P effective load is equal to SF, P effective load into Fs into SW. What is SW? Because SW is nothing but B into Q into dP into K. We know B value, we know Q value. Now this 2Z, this ratio factor we know from this 1.6. dP we know, K is in terms of Bernal hardness number 0.16 into BHN divided by 100 whole square. Now we know this PF. PF is, we know already, 8,000. 597 Newton. Okay. Fs, we know actual Fs, factor of safety. Now we know this values. Substitute here. Finally, we are able to find out this Bernal hardness number. Now this is BHN is 360. Now this is the dimensions of the gears. In the, please, this type of problem, practice it. Okay. Finally, you have to write. This is the design of your gear. This is the design dimension of your gear. Your gear and pinion. Now diameter of the pinion, from this empirical relation we already discussed. You know there's a model now. Substitute the model here. Now number of teeth and pinion, gear, model, and this equation, addendum, dedendum, and clearance, working depth. Substitute your model value. Finally, you are going to get all this data. So finally, this is your design parameter of your gear and pinion. Now I come to the last problem. Last problem. Yeah, here I think this is a 0.25 is 0.34 Levy's form factor. Now I come to the last problem. A pair of spur gear consists of pinion 30 teeth and running of 1000 RPM, transmitting the power. Suddenly. Transmit power, I mean 75 teeth of gear. Okay, the model of gear is 5 mm and the facet is 60 mm. Both the gears made of steel with the ultimate tensile strength is given 450 megapascal. The gears heat treated, I mean Brinell hardness number is given, service factor given, Petrol set is given. Now our aim is to find out beam strength, wear strength of the gear tooth, and amount of power can be transmitted in this gear. They clearly given the problem, wear strength of the gear tooth. Now these are the given data. Yeah, please give me a minute. Just a minute. Okay. Now see here the number of teeth, model, and number of gear teeth, pinion teeth all are given. Pitch circle diameter of pinion also given. Find out the pitch lane velocity. This is nothing but this is the pi dn by 60 e power 3. From these relations, we have found the velocity factor, and the service factor is given. 1.5 already given in the problem. Okay, service factor. Now from these relations, allow permissible bending stress sigma b. Okay, then beam strength is like this simple problem. This is not a difficult one as compared to early one. Okay. Now this is our Brinell hardness number also given 350. Okay. From this we have find out our stress load stress factor. Then wear strength of the gear. Be able to find out wear strength of the gear to be able to find out. Now see here now our SB is less than the wear strength. Now the power transmission must be based on our beam strength only. The beam strength is less than the wear strength. Beam strength is less than the wear strength. Then we have to find out our power based on the beam strength. Why beam strength we are using? Based on the beam strength, I am going to find out my PT. PT only it can be defined our torque. Once we define the torque, we are able to find out the amount of power transmitted. Now PT from this relation we are able to find out PT. Now PT we know once you can PT into V, pitch lane velocity. This way also we are able to find out the torque. Sorry, power. Okay, now it's 11.657 kilowatt. Okay, guys, do you have any doubt? Please go ahead. Now we are entering into the helical gear discussion. Okay, do you have any doubt in the previous problems? Please.
No, sir.
Yeah, tell me, ba, who is this?
No, sir, no doubts.
Okay. Okay, now I come to the helical gear. Now in the helical gear, please you go through that. Terminology of helical gears. Very easy. You can easily understand because most of the things we discuss in the spur gear, the terminology of spur gears, the similar thing. There are little small modification. Only the gear teeth and pinion teeth are slightly designed in angle. Okay, in spur gear, the gear teeth and pinion teeth are parallel to our shaft. But in helical gear, sorry, the gear teeth and pinion teeth are slightly angle of orientation with respect to our soft angle, soft axis, then that is only small variations. Remaining things are same. The same concept, whatever we discussed, Levy's concept, beam strength, and Buckingham's concept, wear strength. The same concept we are going to use here. Okay. Now see here. Now I am directly entering into the force analysis. The terminology of gears and virtual number of teeth, just you go through our Bandari book, you can get it more clarity. Damn sure. I already have gone through that. It's very simple only. It's not a difficult one. Please go through that. If you have any doubt, please get back to into the next class. No problem. Okay. Now we just we see these important things. First we discuss the force analysis. Now, as I told you, when we discuss different types of gears, helical gear, spur gear, helical gear, bevel gear, worm and worm wing, rack and pinion, right? A spur gear we discussed, spur gear we discussed, there are two types of force. One is tangential force, radial force. But in helical gear and bevel gear, what we discussed, is there only two force component or some more force component is there? Please tell me that. What is another force component in this helical gear?
Axial force components, sir.
Yes, exactly. Axial force or thrust force. Okay, thank you. Now this is now we are going to discuss that. Now see this video clearly, you can understand. Now this is anyway the resultant force P is always acting in the normal. Now this is our normal. Anyway, I would like to show you our spur gear also. Now, in spur gear, what are the forces are acting? One force is acting like this. The another tangential force is acting like this, right? Because the gear teeth and pinion teeth are parallel to the shaft. Hence, only two forces. Now, suppose now this is the line. This is the line exactly parallel. Exactly. This is a video. Please carefully see this video. This is the line. This is the gear teeth. Gear teeth line is exactly reflecting our schematic diagram, which one is we are going to discuss now. Now come to this. What are the force component acting here in this? The tangential force is going to be acting in this direction. The tangential force is acting yeah, in this direction. The tangential force is acting now. Tangential force is acting here in the gear teeth, right? See here. This is the tangential force. Where is the radial force? Radial force is acting here. Radial force is acting here along the direction or radius or center of the along the center of the gear or pinion. Okay, radial force. Now, due to helix angle, one more force is presented, that is PA here. Because of this one is PA. Now PA is acting here. That is the third force. We already discussed in the different types of gears, but in helical gears, no axial force. Now that's what. Now the same teeth, this parallel teeth, same design I considered here. Same design. Now see here, this is the angle is nothing but helix angle. Helix angle psi. Now you tell me helix angle psi is equal to 0. Then what type of gear now? Then what type of gear? And PA going to be neglected or considered? PA going to be neglected or considered? when psi is equal to 0. Please
It will
someone
be
write it.
per gear, sir.
Yeah, it will be per gear. So that understanding is enough. Then you go later, you go to the, thank you, then you later go to the terminology of this per gear, helical gear. You can get more clear information. Now see here, now this is yeah. Now see here, when psi is equal to 0, it will become a spur gear. Then the axial component or thrust component going to be neglected. When we are considering psi is equal to 0, is going to be neglected. Now, based on that, you see this is a diagram, schematic diagram. Now, where is the pressure angle? I mean, this is common normal. This is the common normal. That common normal, this is the common normal. This is our common normal. The P is acting in the common normal, right? From this line diagram, clearly, please carefully listen this. Anyway, I have given enough input through this three-dimensional video. This video. Now, this is a three-dimensional schematic diagram here. Now you should understand this is now pressure. This is our helix angle. Okay, this is our pressure angle. This is our pressure angle, right? This is our pressure angle normal. The pressure, I mean, normal to normal based on the our pitch line. Now, this is from this where the force is acting. This is our resultant force. Now, this angle, resultant force. Now, this is angle is our helix angle. This angle is our helix angle. From this diagram, we are able to find out the PT in terms of, I mean, our PT in terms of P or axial thrust or axial force component in terms of PT, we are going to find it out. Now, come to here this diagram. First, I am taking this rectangle triangle. First, I am taking this rectangle triangle. Which rectangle triangle I am taking? Now, first I am taking this rectangle triangle ABC. This rectangle triangle. Okay. From this rectangle triangle ABC. Now, in this rectangle triangle, only we know the component PR. Only we know this component PR in this rectangle triangle. This is our component P. It may be a resultant component. What is the angle? Alpha n. From this rectangle triangle ABC, this triangle, from this triangle, we are able to find out this is the PR, then PR is equal to P into sine alpha from this triangle. Then what is BC? BC is nothing but P into cos alpha n, P into cos alpha n. Just keep in mind. Then another triangle. What is another triangle? Because three forces are acting. PT, PR, PA. Now another triangle I'm going to consider this one. Another triangle I'm considering this one. Now in this triangle, what are the forces are acting? In the, I mean, this is the triangle vertical. Whatever we discussed. Vertical triangle, this one. Which one earlier we discussed? Now I am considering this a bottom triangle. When I am considering bottom triangle, there is the force. two force components are acting. One is this PT, another one is this, another one is this PA. Okay, now the PT is presented here. Now, PT and PA presented in this case. Okay, now use this triangle to find out the PA. PA is nothing but, now what is PA? I mean, PA is equal to BC into sine alpha. BC, we already know this is a BC. BC into sine alpha. PA is equal to BC into sine alpha. We already know from the earlier triangle, BC is equal to PA into P into cos alpha. Then substitute here P into cos alpha into sine psi. Sorry, PC into sine psi. Sorry. This is psi. This is a helix angle. With respect to helix angle, this triangle with respect to our normal pressure angle. Normal pressure angle. Now, because we are considering here alpha and normal pressure angle in the, we considered alpha in per gear transverse pressure angle. Transverse pressure angle. These are the terminology. Just you go through that terminology of this helical gear, you can get it more information. Now this triangle with respect to helix angle, helix angle of the gear, this triangle with respect to pressure angle, normal pressure angle of the gear tooth. Okay, now come to this. Now this is, from this triangle BDC, we are able to find out axial force, axial thrust, axial or thrust component P BC into sine alpha, BC into sine alpha. Okay, BC into sine alpha. Now PT is BC into cos alpha, BC into sine psi, BC into sine psi. PT is BC into cos psi from this triangle. PT BC into cos psi. We have already discussed BC is equal to P into cos alpha n. Substitute here. Finally, we are able to find out our axial thrust is, axial or thrust component PA is equal to P into tan psi. You saw, simplify these two relations C and D. Finally, you are going to get this. Similarly, simplify this equation A and D, then you are going to get PR in terms of PT. And now PR in terms of PT. Now, suppose cos psi is 0. Psi is helix angle is 0. This is satisfying with our spur gear. PR is equal to PT into tan alpha. That alpha I am going to be alpha. Okay. Now this is the information, is very important. Now I come to this. This is a standard calculation. Once we know the PT is equal to 2mt divided by d. From this relation, we are able to find out the torque. Okay, the torque. Now, these are the relation. Just whatever from this relation, we are able to find out the torque. Once we are able to find out the PT, then we are able to find out the PR, radial force and axial force. Axial force or thrust component. Now, how can I understand the direction of the force? That's what. See, very nicely they have given here. The following information is required in order to decide the direction of the three components. Now, ourselves, we are asking the questions. Which driving element we should consider? Which is the driven element? Which is the driving element? We have to first identify. Then, if the pinion is rotating clockwise or anti-clockwise, or the gear is rotating clockwise or anti-clockwise, we have to identify first. And what is the hand of helix? This is the things we have to consider for defining our force direction. Now I come to that. Now see here, for example, the first one, tangential force PT. The directional tangential component for a driving gear is opposite to the direction of the rotation. I tell you how it is. The direction of the tangential component of driven gear is the same direction of the component force PT, component PT. Now see here where it is acting. Now the PT is here. For example, see, this is you may consider now opinion. This is you may consider for gear. For our understanding, please don't say this is a bigger one, this is smaller one. For our understanding, now I am considering this is opinion. Now the PT is acting here. Where the PT is acting here? The PT is acting here now. This is my PT. Now the PT is now PT is acting here. The PT is now, I mean, opposite direction of the our gear, opposite direction, opposite rotation of our gear. 1 minute. Now we are considering PT. Okay, the PT is a tangent component for the driven gear opposite direction of the rotation. Now see here, this is, I might have been put here because it will, if I draw it here, it will be confusing. That's what I have drawn here. Now see here, the PT is opposite direction of our gear. Suppose if you take, but our PT is the same direction of our pinion. Okay. Now, suppose you can take our axial force component. Axial force component is now, this is a rotation. Now, our axial force component is opposite direction of our pinion, but same direction with gear. So based on the rotation, based on this directional rotation, we have to understand which direction the PT and the PA are PA acting. We should understand. That's what. Okay, now I come to the beam strength of helical gear. This is exactly similar whatever we followed in the spur gear. The same thing we are going to follow the concept here. Only the thing is, see here now, I mean, that is the beam strength of the helical gears is considered equivalent to formality of this spur gear. I mean, whatever we discussed earlier. Now, what are the different things we are going to understand? Those things we are going to discuss now. The pitch circle diameter of the gear D dash, the number of teeth is Z dash, and here the model. Now this is MN. Only early normal. Now MN here using normal model. MN is normal model. Earlier we used M is a transverse model in the spur gear. Now this is earlier whatever we discussed beam strength equation. Now see, this is the equation. Now this is the two gears are in, the gear teeth are in helix angle alpha side, this side. Okay, now what is this width? Now earlier the gears are like this, the gear teeth are parallel to the axis of the shaft. Now that time we considered B. Now this is, now we have to consider this dimension. Now what is this? Very simple. Now the face width is nothing but B by cos alpha in B by cos psi. Sorry, cos psi. Now this is our face width of the helical gear. Now face width of the helical gear. Now whatever we discussed earlier, this formula, just see here. Now this is our earlier formula. We consider the beam strength this way. I mean, this is the gear, right? We considered already. Sorry. Because earlier this is the parallel, the teeth was parallel to the our axis of the shaft. Now the teeth is not parallel to the axis of the shaft. Now in this case we considered SB, bending strength. Now this is the SBN, now normal normal to this. Now this is, now I mean whatever we discussed earlier, the same formula, same con. Now this is SBN. Now what is SBN here? SBN here, how can I write it SBN here? I mean SB into cos phi. SB into cos phi. I can write SB into cos phi. Yeah, sorry. Now this is SB, SBN. SB is equal to SBN into cos pi. Cos pi. Cos pi. Okay. Now SBN into cos pi. Now substitute this. I mean Mn. Instead of M, put Mn here. Instead of M, put Mn. Instead of b, put b by cos pi in this formula. SB. Now this is the finally SBN is equal to Mn into b into sigma b into y by cos pi. Cos pi. Now this is what is this? Now I mean now I would like to extend this. We know SB is equal to SBN into cos psi is equal to this equation B. Equation B. Simplify this, then finally we are getting, finally you are going to get SB is equal to, SB is equal to, I mean Mn into sigma B into B into Y. Sigma B into Y. This is our normal model. So this is way we can find out. Then remaining things, effective load, whatever we discuss, the same concepts here also following same concepts. Now only the thing is, this is our effective P, but dynamic load. I mean cos squared pi. These are the new terminology because of the helix angle. Now cos squared pi is 0, then this is going to be satisfying with our spur gear. Okay, this is very, this is the effective load for use considering the dynamic load. Consider dynamic load. I come to the wear strength. Wear strength also. I mean, please go through this our earlier terminology of gear and equivalent. I mean, virtual number of teeth. You can get it more clarity about how this dp dash came here. Then these two terminology we are going to use in our early formula what we discussed in the wear strength. B, instead of B use here B by cos psi, cos pi. dp instead of dp dash use dp by cos squared psi. Finally this is our wear strength. Now whatever we discuss finally that the component SWN in the plane of rotation denoted by SW, what we discussed earlier SBN. Similar way here SW is equal to SBN into cos pi. SBN into cos pi. One small mistake. Did I do any mistake? Sorry. Here one small mistake. Yeah, correct one. SB is equal to SBN into cos pi. Here SW is equal to SWN into cos pi. Similar way. Okay. Now substitute here. Now this is the equate this SW and SW, SW and this SW. Finally, we are going to get this SW is equal to BQ dP by cos squared K into BQ into dP into K divided by cos squared psi. I mean, this is the wear strength for helical gear. Wear strength for helical gear. Okay. Now, so whatever I told, I tell you these things, I write it here. SW is SWN is equal to SWN is equal to SW divided by cos psi. Similarly, here also SBN is equal to SB divided by cos psi. From this relation. Now equate this equation B and C. Finally, we are going to get our required beam strength equation. Okay, see this is the finally, I mean briefly we have been, I mean we can understand here SBN, this is our beam strength of helical gear. Okay, I mean Mn into B sigma B by Y by cos pi. This is our, I mean SBN with respect to normal, with respect to transverse direction. Okay, Mn into B in sigma B by Y. Now this is the wear strength. Wear strength is This is a wear strength. Whatever we discussed, this is for helical spur gear. Then extended to, I mean, our helical gear as W wear strength. Now BQ into dpk by cos squared pi. This is our dynamic load capacity. So that is the, I mean, whatever we discussed the problem, same manner we have to use this formula for defining our gear parameters, module, pitch line, pitch circle diameter of pinion, pitch circle diameter of gear, phase width, and clearance. Everything we have to follow. But I mean, I didn't go through that some of the standard empirical relations. I mean, here they have might have been given empirical relations. Just you go through your book, you can get it. Okay. Now this terminology of bevel gear, now I am not going to spend more time. This important terminology we discuss and we go to the direct formula. So this is a bevel gear also.
Sir,
Yeah, I complete within 2 minutes.
time
I
of
complete. Yes, I complete within 2 minutes. Okay, please cooperate. Now this is the all are simple only. Now this is we have to understand the length, the angle of what are the terminology, important terminology. I tell you that. Now this is the pitch angle is very important terminology. Remainings are we already discussed. Same thing, same similar thing only. The angle that the pitch line makes the angle of axis of the gear is called pitch angle. Let's see here this angle. This one, the angle that pitch line makes the angle of gear. Pitch line angle makes the angle of gear. Okay. Now this is our pitch angle. Pitch angle. Addendum angle is nothing but the angle subtended by the dedendum of the cone. The addendum of the cone at the center. This one. Actually, I have shared video. First, you see that video and you can get it. This is the pitch line angle. This is the sorry. This is our addendum angle. Below one is addendum angle. What is this? What is the phase angle? Phase angle is nothing but this is addendum angle plus our pitch angle. This pitch angle plus our addendum angle. This is addendum angle is nothing but alpha here. Addendum angle is nothing but we are considering delta here. What is here? Phase angle is phase angle. Phase angle is y plus alpha. This is a total angle. First, I come to this total angle. I complete within 2 minutes. Total angle here. This is a phase angle. Total angle. Y plus alpha. Root angle. Pitch angle minus pitch root angle. This is a root angle, right? Hence, pitch angle minus our pitch angle minus our dedendum angle will give you root angle. Root angle. Okay. These are the things very important. Root angle, phase angle, dedendum angle, addendum angle. These are different terminology. And backbone distance. Backbone distance is this is A0. From this point to this point. The length of the backbone element, it's called backbone radius. Backbone radius, I tell you this. See here, from this point to this point, extend this line. Backbone radius. This is the, this is the formula. Wear strength for bevel gear. This is the called bevel factor. When bevel factor is 1, it will be a spur gear. It will be a satisfying the spur gear. This is the wear strength formula for bevel gear, and this is the dynamic load capacity for the bevel gear. Please, this is the formula, just you remember and see the problems in your book. I'm not going to discuss further more about this. Okay. And this is the warm gear. Warm gear, simple, very simple. Just you go through your book, Bandari book 744 to 745. Not only this, I give later, I will mention the pages. Later I will mention the other pages also. You refer that, you can get clarity. Okay. But you mostly concentrate up to spur gear is very important. Helical gears, also important, but the bevel gears just to practice your own. Okay. Yeah. Okay, any doubt, please go ahead.
No doubt.
No doubt.
Yeah. Okay, guys, the next class we are going to start our sliding contact bearings. Just I give the introduction, just a minute, then I stop it here, because we whatever we planned it, just we go through just 1 minute. We discuss what is the bearing. Please, someone reflect.
Sir, we have another class.
Yes, yes, I close it now. What is the bearing? What is the bearing and what is the application? Please, I stop it based on your answer. I stop it.
Sir, reduces the friction between different components.
Yes, very good. Reduce the only, will it reduce the friction between two components or any other explanations? Please. You are telling.
Facilitate smooth rotation of the component, sir.
Yes. Okay. Smooth rotation. Okay. In the first class, I think the soft couplings, I have shown you one diagram. The same diagram I'm going to follow up to end of this subject. Not only reduce the friction, it will be supporting the radial load, axial load, simultaneously transmit the power without any jerk. See here, this is the bearings act as a support. Also, it should freely allow the rotation of the shaft, acting as a support, and simultaneously allow the free rotation of the shaft to transmit the power from one place to another place. For example, this is a connected to motor. Okay, this is the connected to somewhat rice mill machine, some machine or generator. This is connected to the belt drive. Now, without support, without shaft, we cannot transmit this power. This is motor. From this place to this place, I want to transmit the power. Without shaft, without support, we cannot do. Hence, we need a support. That support should allow our other components free rotation. Should not prevent the rotation of the component. Hence, the bearing, it will be acting as support. It will allow the free rotation of the component for transmitting the power from one place to another place. Hence, bearing is very, very important. So we are going to discuss different types of bearings. So the bearing component, that's what, then remaining things we will discuss in the next class. So this is the support. This support going to be fixed in the base. This is going to be connected with the shaft. The shaft will be later connected to the gears or pulleys based on our power transmission requirements. Okay, guys, thank you. If you have any doubt, please go ahead. Yeah, where is this screen? Yeah, Kalyan. Guys, any doubt?
No doubt, sir.
Okay. Exactly 1 hour 15 minutes, 1 hour 14 minutes the video recorded. Hey Kalyan, I shared video. Is it clarity? Because Is it clarity in the video? Have you checked the video in LMS?
It is okay, sir.
Okay. You tell me any issues in the video, blurring or blurring effect or something, not clarity, then intimate me. Based on that, I can go ahead, because even I can use this screensaver software also to take the record the video.
Okay, sir.
Okay, guys, any other doubts or any other things, please share with me. Based on that, your input, I can teach you. Based on your expectations, I can teach you. No problem. Stop sharing. Oh, stop sharing. How many students, Kalyan, attended? Hello?
Around 60, sir.
Total numbers? Let me know, please.
88.
80 people attended, 80 students?
No, sir. 60. 66, sir.
Yeah, please inform the students. 88 students are there in the section, right?
Oh, yes, sir.
Yeah, please inform them I'm not happy. The tomorrow class, it will be serious. I'm going to take attendance. Please, the last two sections, can you share me the attendance?
Sir, in WebEx, attendance will directly be recorded, sir, in WebEx.
Is it? Record attendance where I can download? Guys, please, remaining students, you may leave the class. Yeah, sorry, you can leave the class. Just some of the small